out to 7.5 feet.
Plus the height of the table.
Oh, right. So that is about 3 feet.
3 feet? Okay.
So the height of our wall works out to be 10.5 feet.
Cool. 2 easy methods for measuring just about anything, even distant mountaintops.
Wow.
Cool. But from now on, somebody else can do this.
I'll do it.
Okay.
Yeah, we'll look from below.
Yeah, I will calculate.
Okay, so hopefully everybody can see here that we are going to be doing different things, but it's really useful. That's my favorite thing about this. This is a right triangle chapter. It's probably my favorite chapter, I've got to be honest. And this stuff that we're going to learn, like they were saying, the tangent and the geometric means, I'm sure you've seen them in some other classes as well, but I'm going to totally treat it like you've never seen it before. You also know, of those of you who raised your hand, can somebody actually tell me what the Pythagorean theorem says? Like, how do you remember it? Anyone? Yes, Echo.
A squared plus b squared equals c squared, and then memorize that by using like 3 rectangles and then squares, and then you can just
right. So, and I know everybody knows that formula, and if you don't, you're going to learn it and you're going to love it. A squared plus b squared equals c squared. So before we actually start, that was our opener, and you can see you'll be able to use those same methods to find heights and things like that. We're going to review square roots, because when you square things for the Pythagorean theorem, you have to undo them too. And I always find, I've been teaching a long time, and I find that every year students struggle with it because they just need to be reminded. So I'm going to go right now to my student journal. This is a mathematical, it's a proficiency that we need to review just quick before we jump right into the Pythagorean theorem. So I'm going to go to the camera. Make sure I share my screen. And then go to the camera. So this is, like I said, page 241. Please have that in front of you so we can do them together. Let me get these other ones out of the way. I already have my other notes ready. So I'm not going to assume that any of you know anything about square roots. What I need to remind you of or teach you is that each of these numbers can be broken down. And the key thing is the factors of the numbers cannot contain any of these numbers. I call them square numbers, but it means the square of a number, right? So 2 squared is 4, 3 squared is 9, 4, 5, all the way up to 100. Of course, you should know more than that because you know at least up to 12 times 12. But if any of the numbers that are factors that are here, then you have to take those out. You can't leave them under the radical. And one of the reasons we're going to do this to simplify is because this is like an improper fraction. Okay, it's too big all by itself. So what I'll do is I'll figure out how many different numbers are products that we can get, factors out of 500. So like I know that 5 times 100 is 500. I know that 2 times 250 would work. I know 50 times 10 would work. So there's a number of different things that'll work. How do you know which one to pick? Well, that's where this list comes in. So I could go down this list and say, oh, look, 25 goes into 500. I could do that. But what you really want to do is pick the biggest one. So that's why I would continue down here to 100. I would choose 5 times 100 rather than 25 times 20, because the bigger it is, the easier it'll be to reduce. So I'm going to change this so that it looks like root of 100 times root of 5. Those are equivalent. But I know that the root of 100 is 10 because 10 times 10 is 100. So this is just going to turn into 10 times the root of 5. And that is as simplified as it can be. Anything under the radical no longer has any kind of square number in it. And so there you go, because the factors of 5 are just 1 and 5. I'm looking at number 2. This is 189. 2 won't go in it, but maybe 3 will. So remember your divisibility rules, 1 plus 8 plus 9, that's 18, and 3 will go into 18, so it works. 3 will go into 189. I don't know how many times, but I always have my calculator with me. So let's see, 189 divided by 3. Look, that gives me 63. Okay, so that's going to give me 63. Well, this is okay, but this is not, because now I see that 63 is 7 times 9, and 9 is a number in this list. So I'm going to have to write this as 9 times 7. I still have the 3. Okay. And these are all multiplied. So now this one I can change into a 3. But then this one, 7 times 3, I'm going to put it back into the radical because you can't just leave it like that. Another way I could have done it was I could have gone straight to root 9 times root 21. That's another set of factors for 189. But it doesn't matter where you start. You will always end up with the same number. So hopefully you can see that that's also root 21. Now number 3, again, it's a big number. I don't know what I do know 2 goes into it, clearly, because it's even. I wonder if 4 goes into it. So 252 divided by 4. Oh, that's 63. Okay, so look, I can go 63 times the root of 4. And then I already know I can change that one too. So this is 9 times root 7. I still have the 4. So these two things are going to change. The root of 4 is 2. The root of 9 is 3. So this is going to turn into a 3. This is going to turn into a 2, and you multiply them together. And so that's like reducing. And again, I could have also gone straight to 36 times root 7, but I didn't assume that you would know that. Okay, any questions? The second skill we're going to talk about on simplifying is changing fractions into whole or rational numbers. So this is, you have to rationalize it, meaning you cannot have decimals or fractions under the square root, but you also can't have square roots under a in the denominator of a fraction, because it's like a decimal. So in order to rationalize it, we're going to take that square root number and we're going to make it whole by multiplying times another root 3, because root 3 times root 3 will turn into a whole 3. If that doesn't make sense to you, or if you never learned this before, please make sure you are following along carefully and let me know, and I'll help you out. Now, I can't just multiply willy-nilly because that would change the value of the number, but I can I can multiply times the equivalent of 1. So if I multiply root 3 over root 3, that's just like multiplying times 1. And then on the top, it's 4 times the root of 3, but on the bottom, root 3 times root 3 just turns into a regular 3. So this is okay. It's okay for that to be in the numerator, just not the denominator. For number 5, same thing. I'm going to rationalize the root of 5, and I'm going to multiply the whole thing by the equivalent of 1. So on the top, I get 11 root 5. And then the bottom I get 5. And that's it. There's nothing more than that. However, for number 6, slightly different. And the only reason is now something that we're going to do the same process, multiply times the square root on the bottom. So I'm going to get 8 root 2 on the top, and then on the bottom that turns into a whole 2. But the reason this is different is because 2 will actually divide into 8, right? 4 times. So you'll end up with 4 root 2 and no denominator. Again, any questions? Pause that. Okay, so you guys, this second part, I know you already know how to do because you just did it in chapter 8 quite a bit, especially these single proportions. You just do your cross product. But on these two down here, if you have, and when you have, something with like a binomial with 2 terms, xn minus 4 or 5x plus 25, you have to do the cross product. And I just wanted to remind you that each one of these is a whole number. So x minus 4 is a number. It can't be separated. You can't forget about it. This turns into 9 times x minus 4 this way. And that's going to equal 5 times 10 that way. So you end up distributing the 9 times x, 9 times 4. Then I'm going to add 36 to both sides. And now I'm going to divide both sides by 9. Now, I don't know what 86 divided by 9 is because it's nothing even. So I'm just going to go like this. 86 divided by 9. That gives me 9.6 or 9.55. If you wanted to, you could leave it as 86 over 9 too. There's nothing wrong with that. If you don't have your calculator with you, just leave it as 86 over 9. This one is going to be 135 equals 3 times 5 is 15x plus 3 times 25 is 75. Subtract both sides and divide both sides. Of course, you'd want to check it too, but that's as much of review as we're going to do of square roots. You're going to get a lot of them throughout the chapter. Okay, so I'm just going to stop and ask you to grab your notes. But again, this was in your journal. And I'm hoping that's enough of a review. Like I said, when we do the Pythagorean theorem, you're going to get a lot of practice on this. So we're going to start with our, class notes right away. This is 9.1 if you want to follow along in your book. The lesson objective here is that I want students will be able to apply the Pythagorean theorem. And guess what? It has a converse. I also am going to ask you to determine if a triangle is acute, right, or obtuse, and you can also do that with the theorem. By the way, Pythagoras, one of the most famous dudes, named for the ancient Greek mathematician Pythagoras. He actually had like this whole academy on this little island off of Greece, and it was sort of a secret society, but carved into stone across the beginning, the opening of the place, the academy. He had the words etched, "Let no man unversed in geometry enter here." I thought that was a really cool big deal. So when I first started teaching and I was teaching geometry, I made this huge banner and put it up in my classroom. "Let no man unversed in geometry enter here." Okay, so done with my reminiscing. So I'm going to go through this quick because I know you guys all know this. You just need a reminder. First of all, in a right triangle. So the first thing you need is a right triangle. But in a right triangle, the square of the length of the hypotenuse, which the hypotenuse is always the longest side, and it's always the one across from the right angle. Even if it's upside down, it's still the one that's across from the right angle. So the square of this is equal to the sum of the squares of the other two legs, which means if you have a right triangle, then a squared plus b squared equals c squared, like this picture. A Pythagorean triple is going to super duper help you out, especially if you're really good with numbers in your head. It's a set of 3 positive integers, A, B, and C, that satisfy this equation. So you may actually already know about this. A 3, 4, 5 triangle fits like this: 3 squared plus 4 squared plus equals 5 squared. Because that's 16, that's 9, that's 16, and that's 25. So you add them together. So this works, which means if those numbers work, then any similar triangle in that same ratio will also work. So if I tell you that you have two sides of 30 and 40, then you know that x is 10 and the third side is 50 without even doing the calculation. You can just use that ratio. Or say I tell you that the two sides here are 18 and 24. Well, that's 3 times 6 and 4 times 6. So without even solving, you know that the hypotenuse is 5 times 6, so that would be 30. And that's the way these triples are very handy. So you see that's 25, and that's 144, and that is 169. So you add them together. Again, you get this ratio. This side's 5x, this side's 12x, and this hypotenuse is 13x. Another one is, 8 squared plus 15 squared equals 17 squared. So that means that even longer and skinnier, any ratio with these same numbers will also work. And this is really handy to save time on standardized tests. So if any of you want to are going to take the KC or the SAT, knowing these triples are very handy. It can save you time, which you'll see when you start doing the problems that way. Okay, so I'm going to find the exact value of x using this. In this case, and then I'm going to tell whether the side lengths form a Pythagorean triple. So this is C. This one's either A or B. That doesn't matter. We're solving for x. So a squared plus b squared equals c squared is going to give me 7 squared plus x squared equals 14 squared. Well, I know this is 49. And you know what? I don't know this. I think it's 196. Yeah. 196. Then I'm going to subtract, and I get 147. And this is where our square root comes in, because I don't want x squared, I want x. So if you don't remember this, to undo x squared, do the inverse operation, then I need to take the square root of both sides, because the square root of x squared is x. And then here's the thing, root 147, I want an exact value. If I just did this, 147, no, I think I have to do that backwards. If I just did the square root of 147 like that, this is the answer we're looking for. It's exact. It's not the decimal, okay, which comes out to be like 12.12 or something like that. So what I'll have to do is break this down into 49 times 3, just like we did on our practice before. And then x is equal to 7 times the root of 3, because the root of 49 is 7. And this is what we call exact. So if you did do this, if you did 12.12, that's an approximation. We don't want an approximation, which my other calculator will do. I have it set this one to do the radicals. But if I did 147 square root here, it'd give me that. That's an approximation because it's not exactly the root. So if it says find the exact value, then that's what you need to enter. Okay. Then I would ask, so by the way, does this form a triple? No, it's not a triple. No, it's not a triple. Always have to answer our questions, whatever's being asked. Any questions so far? And I'll slow down if there are. Okay. Now we've got a real problem here, like a real life problem. Imagine that. The flagpole shown is supported by wires attached to the ground. Use the Pythagorean theorem to approximate the length of each wire. So this is what we're looking for. That's our x. This height right here says it's 15.1, and this right here is 8.5. So we can use the Pythagorean theorem to find x. It's going to be 15.1 squared plus 8.5 squared. It's going to equal x squared. It says this one's to the nearest tenth. So that means we probably can just use our calculators doing this. 15.1 squared, let's see. 15.1 squared plus 8.5 squared. That's going to give me 300.26. Okay, since we're doing the notes, I always like to color code, as you know, but I want to undo that square so that I just get that x equals this, and I can just do the square root of the answer here should give me a decimal. Yeah, 17.33, but it says to the nearest tenth, which is just one decimal. And those are feet. Always do our units. Okay, so you probably know this already, even though it begs to be said, there is a converse of this. If we have a right triangle, then we get the relationship of a squared plus b squared plus c squared. That's your conditional. However, the opposite is true. If you have a squared plus b squared equals c squared, then you get a right triangle. So it's like a way to prove it. As you know, we love our proofs. Okay, I'm going to turn this over. We're just going to tell if they are a triangle. That's it. So these two, 7 and 8, this square root 113. I know it has to be more than 10. It's more than 10 because the root of 100 is 10. So if this number is more, so if this is more than 10, then that has to be C. All right, so I'm going to do 8 squared plus 7 squared equals the root of 113 squared. So I get 64 plus 49 equals 113. And what I'm doing is I'm checking this. Is this true? So that and that is 100. That and that is 13. So it is true that yes, it is a right triangle right there because of that. Now I'm going to look at this one. Same thing. Let's see. Root 95. Well, I know that's going to be a little less than 10. And 10 is times 4 is going to be about 40. So this is definitely my hypotenuse. So I'm going to do the same thing. 4 times root 95 squared should equal 36 squared plus 15 squared. Now, I don't know what all these numbers are, so I'm going to grab my calculator. Okay, so 36 squared plus 15 squared. I'll do the right side first. This is 1521. And now this one is going to be 4 times the square root of 95, and then I'm going to end my parentheses. So it's just that one number. I get, oh my goodness. I want to square that number. There we go. So that number squared is 1,520. So they are not equal. So no, it is not a right triangle. Any questions? Please ask questions if you need to. So we're going to take this relationship right here, like what we just did. If it's exactly spot on, a squared plus b squared plus c squared, you've got a right triangle. But if it's not, if one of these numbers is bigger or smaller, you can tell if it's acute or obtuse. Because remember, all you need for obtuse is one angle greater than 90 degrees. So for any triangle ABC, where C is the length of the longest side, the following statements are true. If these two squared and summed up are greater than C squared, then you're going to get a teeny tiny small acute angle. However, if a squared plus b squared is less than c squared, right? That means this is going to be a really small one, and that means that this is obtuse. So this will give you an acute angle, this will give you an obtuse angle. So what we'll do is we'll do one of each, but you're just using the Pythagorean theorem. So what type of triangle, if at all, do the following side lengths make? First thing you have to do is check and see if it's a triangle. Okay, so is this a triangle? Remember our theorem that said that the two shorter sides have to add up greater than the longest side? Well, clearly this is true. This is going to be 9.5 is greater than 6.1. So yes, it's a triangle. That means now we can try and see if this works. So 4.3 squared plus 5.2 squared equals 6.1 squared. And we're just going to see, is it equal? Again, grab your calculator. 4.3 squared plus 5.2 squared. That's going to give me 45 that's a 5.3, and 6.1 squared is going to give me a 37.21. So this one's bigger, which means a squared plus b squared is greater than c squared, which means it's over here. That's this one. That means that it is an acute triangle. Okay, and number 5, what type of triangle, if at all, do the following sides make? 3, 4, and 6. So let's check to see if it's a triangle. Are 3 plus 4 greater than 6? Yes, so it is a triangle. I'm going to check that. Now we know that, we can do the Pythagorean theorem. 6 has to be on this side. And we'll put the question mark in between. So this is 9, this is 16, this is 36. Okay, 36 is larger than, which means here's our C. So this meets this requirement, a squared plus b squared is less than c squared. That means it is an obtuse triangle. So Pythagorean theorem is really handy. And you're going to be doing problems. Like I said, keep your calculator handy. There are 20 problems on big ideas for this. Just 20 problems. But it's review. And then depending on how I feel tomorrow, I may give you even more time tomorrow before we move on to 9.2. But we'll see. I'm going to do my very, very best. Look on the agenda. It is 12:16. I'm sorry that so much of the class was done doing notes. Okay, but because it was review, I thought more examples would help. And now you have those, you have the big ideas assignment. I do believe it's already popped up for you. So let me just quick check. But I believe that will be, let's try to restart the thing.